In this lesson, we're going to talk about how to graph more complicated rational functions that have quadratics in the denominator, where the quadratic doesn't, one of the factors doesn't cancel out and create a whole. So imagine we want to graph the curve y equals x squared minus 1 over x squared minus 4. First things first, we're going to factor numerator and denominator. And we see that there are no wholes, because there's no factor of the denominator that cancels out with the numerator. But we do have a couple of vertical asymptotes, x equals 2 and x equals negative 2. Now, let's think about horizontal asymptotes. We have a degree 2 polynomial over a degree 2 polynomial, and the x terms don't cancel out of the denominator, so we're going to have a horizontal asymptote at y equals lead coefficient of numerator over lead coefficient of denominator. In other words, y equals 1. Now, it's good in a question like this to determine what the x and y intercepts are. So to determine the x-intercepts, we let y equal 0. Well, if we let 0 equal x minus 1 times x plus 1 over x minus 2 times x plus 2, we can multiply both sides by the denominator, and we're just left with 0 equals x minus 1 times x plus 1, meaning x minus 1 is 0 or x plus 1 is 0, so x is either 1 or negative 1. So we got a couple of x-intercepts. Those will be useful to us. And it's good to also know the y-intercept. And to do that, we'll let x equal 0. Pretty simple process. We get negative 1 over negative 4, or in other words, 1/4. We've got ourselves a y-intercept at 0, 1/4. Now, we note our one horizontal asymptote, our two vertical asymptotes. We've got two x-intercepts and one y-intercept. That's a lot of information. Let's do a horizontal asymptote analysis. We're going to let x be a value far to the left of any break in the domain. So we choose negative 100. Letting x be negative 100, we end up evaluating y, just plugging it into the original function. When we do that, y is a number slightly greater than 1. What that tells me is that to the far left, because remember, x is negative 100, which means far left. To the far left, the y value is a little bit greater than 1. In other words, it's above the horizontal asymptote. And that tells me that we're going to be approaching the horizontal asymptote from above to the left. Okay? And if we let x be 100, like we are here, what we're doing then is we're seeing the behavior to the far right. And when we plug that value in, we actually get the same number coincidentally. It doesn't always work that way. That number is slightly greater than 1, which means to the far right, the horizontal asymptote the curve approaches the horizontal asymptote from above. Okay, so now let's do a vertical asymptote analysis. You've seen in a previous video that we call this an epsilon analysis, where we let x be, let's say if we're testing the vertical asymptote at x equals 2, we let x equal 2 minus epsilon or x equal 2 plus epsilon. When we've got two vertical asymptotes in one question, we will instead make it a little bit easier. And for instance, if we're testing the vertical asymptote at x equals 2, rather than let x equal 2 minus epsilon and 2 plus epsilon, we will let x be 1.99 and 2.01. It kind of serves the same purpose. It's not as elegant, but it's going to still give us an idea of the behavior of the curve on either side of that vertical asymptote. So one of our vertical asymptotes is at x equals negative 2. Slightly to the left is negative 2.01. When we let x be negative 2.01, y is approximately 75.8. And that tells me the point negative 2.01 and approximately 75.8 is on the curve. Why is that useful? Well, because if I've got a vertical asymptote at x equals negative 2, and I know that the point negative 2.1, 75.8, 2.01, 75.8 is on the curve, that tells me that that curve on the left side of that vertical asymptote is going up to infinity, and that's going to be some useful information. So to the left of the vertical asymptote at x equals 2, y goes to infinity. Well, let's let x be negative 1.99. And when we do that, evaluate y, we get negative 74.2. Well, that tells me that slightly to the right of x equals negative 2, y is going down to negative infinity. Now, barely to the left of the other vertical asymptote, x equals 2, we let x equal 1.99, and y is negative 74.2. So we see that y is going to negative infinity to the left of that vertical asymptote. And to the right of that vertical asymptote, we're letting x be 2.01. We get a y value of roughly 75.8. And that tells us that y is going to infinity slightly to the right. So all the stuff that we put in red, we're going to summarize it, and we've got it indicated here. We're going to do our best job to graph a curve that respects everything that we have listed. Now, is this going to be a perfect curve? No. When you take calculus, you're going to learn some more methods that are going to be more helpful with more curves. But this is a decent idea of what the curve looks like. Okay? Now, like it says here, we'll learn more about how to graph these in calculus. Well, now, what if instead of x squared minus 1, it's just x minus 1 over x squared minus 4? Well, let's go through the same process. In this case, the degree of the numerator is less than the degree of the denominator, so we definitely know that we have a horizontal asymptote at y equals 0. We don't have any holes, but we do have a vertical asymptote at x equals 2 and x equals negative 2. When y is x minus 1 over x minus 2 over x plus 2, we have an x-intercept where the y coordinate is 0. Letting y equals 0 and solving for x, we get x equals 1, so we got one x-intercept this time. We also have a y-intercept at 0, 1/4. How do we find that? We just let x equals 0 and evaluate y. Okay, now to do our horizontal asymptote analysis, we'll let x be to the far left. We'll use negative 100 in this case. Now, when we let x equal negative 100 and we plug it in, we get a number, we get a value for y of negative 101 over 9,996. This is slightly less than y equals 0. Now, you might think, well, why are we comparing it to y equals 0? In the first question, we compared it to y equals 1. The reason we're comparing it to y equals 0 is because in this question, that's the horizontal asymptote, y equals 0. In the previous question, it was y equals 1. So this is slightly less than y equals 0. That means we're going to be approaching to the far left this horizontal asymptote from below. Well, now let's let x be positive 100. We'll test the behavior to the far right. And when we do that, when we let x be positive 100, we get a small number but slightly greater than 0. That means the curve's going to approach the horizontal asymptote from above to the right. Okay, now our vertical asymptote analysis, as we said before, when there's only one vertical asymptote, we'll use epsilon in this analysis. When there's two vertical asymptotes, we'll lighten your load a little bit. We'll just let epsilon, so to speak, be 0.01. So we've got a couple of vertical asymptotes. One's at x equals negative 2. So we're going to let x equal negative 2.01. Plugging that in to our function equation, we have a y value of approximately negative 75.1. So we know that slightly to the left of the vertical asymptote x equals negative 2, y is going to be heading to negative infinity. Slightly to the right of that vertical asymptote, because negative 1.99 is slightly to the right of x equals negative 2, slightly to the right, we get a pretty significantly large positive number. That means that y is going to positive infinity slightly to the right. Now, going slightly to the left of the other vertical asymptote at x equals 2, we get a y value of negative 24.8. So y is going to be heading to negative infinity to the left of that vertical asymptote at x equals 2. But to the right of that vertical asymptote at x equals 2, y is a pretty good sized positive number, meaning we're going to be going to positive infinity. So we put everything that we know together in one curve. And when we do this, we're probably going to get a graph, whoops, a little bit of a scramble there. But we're probably going to get a graph that looks something like this. Now, we don't want it to fail the vertical line test, obviously. And it's not too easy to draw on this tablet, but we're going to get something that looks something like that. That's a much better job. I was able to draw that on paper. Okay, so that's what our curve is going to look like. Now, you might say, whoa, sir, how can it possibly have a curve crossing a horizontal asymptote? Well, the truth is that a function may cross a horizontal asymptote because it's only as the x value approaches infinity or negative infinity that the curve doesn't cross the horizontal asymptote. So that point that we have circled there is allowed. And hopefully that was a useful lesson for you.